Okay, this video is going to be about file systems and files and directories. Kind of what are they, how to create them, how to manipulate them, and we'll be using files throughout the duration of this course, so it's really important that you have at least a basic understanding of what these constructs are. Alright, we've all used files before, but underneath the hood we need to understand a little bit about them. Computer systems save data. All data is saved in some numeric form. Okay, so even when we have a Word document or a text file or any kind of file, it's all underneath the covers being stored as a numeric value. All right, and we'll get into why that is in upcoming videos, but it's important to know that everything is a number in computer science. So when I save something on a hard drive, I'm saving a number to that hard drive. Even if I've got text saved in a file, that text is translated into a number. All right. The way that translation happens is, in the simplest form, is with the ASCII code. So there's an ASCII table. Every single character you type, so if you look at the capital A here, there is a numeric value associated with that. The decimal value for the letter A is 65. Okay. The decimal value for the capital letter B is 66. All right, all the way down through here we get to Z. The decimal value associated with the capital letter Z is 90. All right, every single character on the keyboard that you see here has a numeric representation. So as I type these characters into a text file, the computer is actually just saving a number. And the reason it's just saving a number is because the hard drive is composed of magnetic switches that are either on or off. And so we can make numbers with groupings of these magnetic switches. All right, we'll go in more detail about the binary system and these types of magnetic switches, but for now just know that all data in a file, even if it's just a text file, is in the end translated to some numeric value and stored on the disk as magnetic switches. All right, so we can translate the letters to numbers and then the numbers to magnetic switches. All right, so notice also that the uppercase A is the letter 60, is the decimal number 65, but the lowercase a is a different number. That's the decimal number 97. Okay, so there is a numeric distinction in terms of the computer's understanding of what we're typing. There's a numeric distinction between an uppercase and a lowercase letter. So throughout the duration of this course, it's really important that you name things exactly as I specify. For this exact reason, the computer understands capital A and lowercase a as completely separate characters. So if I name something lab 1 with a capital L, that's a different collection of numbers than lab 1 with a lowercase l. All right, so it's very, very important. This is called case sensitivity. All right, so the different letter casings have different numeric values assigned to them. Okay, so we need to know how to create a file. All right, so let's do that with the terminal first. There's lots of different ways to create a file. So for this example, I'm going to start out just working on my local machine. I'm not going to log into the CS server yet. So I'm going to change directories to my desktop, and as I create files, you should see them appear on my desktop. Now all of these commands you can use on the CS server as well. All right. So first, ls lists out the contents of my desktop directory. Okay, and see we have junk and dev. This trash can is not technically a file. It's a different construct of the operating system, and that's beyond the scope of this course. But these two directories here are actually listed in my desktop directory. All right, so if I want to make a file, the easiest way to do that is with the touch command. So I want to make a text file, file.txt. Okay, now I'm creating a file. The name of my file is file, and then I have this period. This is an extension, dot, and then the txt tells me what type of file it is. Now I get to make this up. All right, Windows operating systems and sometimes Macs will hide this extension from you. Personally, I think that's a very bad idea. So in all of my operating systems, I make sure I can see that extension. It lets you know what type of data you're working with. So I have a file named file.txt, and if I touch that file, I have created file.txt, and you see it appeared on my desktop. If I list out my files, list out everything in the directory with ls, okay, I see file.txt exists. I can list things out with more information using the -a option, and I can list things out vertically with the -l option. So I can combine those two options together. So the command is ls and then space, and then I provide my options. I provide options after the dash. So dash, I want to list out all of the items, including the hidden items, and then I want to list things out vertically with the L option. So ls-al, we will use that a lot. Okay, so now we see things are listed out vertically. All right, so I have, everything's in alphabetical order, so I have my dev folder, I have junk, and then I have file.txt. All right, and we see this is the size of it, and there's nothing inside of that file. All right. But we do have timestamp information. Right? This is at 1435 is when this was created. Right? So that's military time. That's 24-hour clock. So every time I run the touch command, that should get updated. All right. So now let's look at it. ls-al 1436. Okay, basically the touch command just updates the modified time of the file, and if there is no file, it goes ahead and creates one. So every time you run touch, it's creating that file and modifying it, at least modifying the time. If the file exists, it keeps all the data in the file, but it modifies the last time, or it updates the last time it was modified. Okay, so this is a simple file that contains no data. Now, I can look and see what's inside of this file with the cat command. Cat stands for concatenate, and I'll explain why that is in a second. Okay, so I can type the cat command. In Linux, when you're typing commands, you always type the command and then space, and every space that you add is called, everything after that space is called an argument. All right, so I have an argument that is the path to the file. So file.txt. This is the file name. If I add another space, that's called providing another argument or another piece of information to this command. All right. For this command, right now we just want one argument. Okay. Okay. So nothing happened. There was no output. That's because the file is empty. All right. So let's try to add some information to this file. The easiest way to do this is with our operating system. Most operating systems have some sort of functionality for this. Windows, Mac, you open it with a simple text editor. Not something complicated like Word. You need a very basic text editor. Okay, so I recommend getting Atom. That's one of my favorite text editors, and I'll put up a tutorial on how to use that. But in Windows you have Notepad. Mac has one as well. The Windows and Mac default text editors are pretty terrible, so you're going to want another one. The Linux 1G edit is pretty nice. So this is just a simple text editor, and we opened it up and there's nothing in here. All right. We can also edit the text from the terminal directly. All right. So let's first just use gedit on Linux. This is a basic text editor. It's not a Word document. All right. It's just basic text, and we call that plain text. And I can say something like hello, exclamation point. And then when I press the enter key, I'm actually adding a hidden character to this file. It's called a new line character, but that tells the text editor to move to another line. Every single one of these characters we saw when we were looking at the ASCII table. The capital H has the value of 72, an E has a value of 101, and we had two L's, 108, and an O at 111, right? And then the exclamation point is in this list here somewhere, right there. Decimal value of 33. All right, so that's what's in this file. But then we also added a new line, which is, it's an invisible character when we look at it in the text editor, but it is actually stored just the same way as any of these other characters. It is stored as numeric data. All right, so over here we can look for new line. New line, line feed. So that is 10. Alright, so a lot of these characters are invisible. Even the white space, just a blank space, has a numeric value. And when you type a space, it's actually stored as a number and stored in that file. On the computer, it's stored as a number, right? So invisible characters, like a space, here we go, is 32. That's just a plain space bar press, alright? There's also tabs, right? If you press the tab key, that's only one character, even though normally when we see it represented, if I go back to text editor, if I hit tab, normally you see a tab represented as multiple characters, right? It's actually just one. And a lot of times a text editor will convert tabs to a certain number of spaces, but the actual tab character is just one character when it's saved to the disk. Alright, so it's important to know that that new line character does exist even though we can't see it in this file. Alright, so we'll save this file now, and it just says hello with one new line character. And now we'll use our cat command again. Now cat stands for concatenate, but it's what lets us see what's in a file from the terminal. Okay, it'll just print out what's inside of the file. There it is. We see hello and then our new line character print out. We know there's a new line because it gave us an extra blank space down here. Okay, so we can also edit files with the terminal itself. So we use gedit, which is just a text editor, and it's graphical. When I open gedit, I get a window and I have a cursor and I can use my mouse and I can highlight. I can't do any of that in the terminal. It's almost as if the mouse doesn't exist in the terminal. Okay, so I can say nano, that's the name of the text editor, so this is just like any other command. Cat is a command, and then we have a space, and we provide arguments to that command. Alright, nano is a command. It opens the text editor, but I can provide arguments to that command. What file do I want to open? I want to open file.txt. Okay, so now you see my entire screen has changed. I'm no longer at the Linux command prompt. My whole terminal window has been filled up by this text editor. Okay, here we've got a label. I'm running GNU Nano, the version number, right? Here's the name of my file, and here's the contents of the file, and then here is a bar of some of the shortcuts you can do. All right, some of the things you can do in Nano. So the most common thing to do is you can use your arrow keys and everything, and I might just add a couple lines. How are you? Add a new line. Now I might want to save this file. Okay, so to save all of these shortcuts here, they have this little caret in front. That caret means use the control key and then that letter. Alright, so if I want to save a file, I'm actually writing this data out to the disk. This is kind of older terminology. The Nano program has been around for a long time, way before, well, text-based editors have been around way before graphical ones. Okay, so they were more literal when they say, we're used to the terminology save. Older systems used write out because you were writing data out to disk. They were more literal about what these commands did. Okay, so if I want to write the data out to the disk, if I want to save my file, I hit Control-O. Alright, and then it's asking me, do you still want it to be named file.txt? And I just press enter. Yes. Okay, so now I have saved my file, and I can exit Nano with Control-X. So here on the label, remember that little caret means control, and Control plus X means exit. Okay, so I've exited. I can type ls to see, ls-al to see what's in my terminal window. Alright, I still have file.txt, that didn't change. And now I can run cat to see what's inside of the file. And remember that stands for concatenate. So let's see what's inside of file.txt. Hello, how are you? So now I see I have my extra line of text, and I have some extra new lines as well. So all this is doing is printing the contents of the file out into my terminal screen. This process is called standard output. Alright, so I'm printing the contents of the file to the standard output of the terminal. Okay, there's standard output and standard input. And there's also standard errors. So if a program fails or a command fails, there's a standard error. Okay, so you can think of these as three kind of channels to communicate with your terminal. Alright, standard output prints things out to the terminal. Standard input allows you to input data to a program. And then standard error is if there's an error message. And usually standard error prints out to the terminal also. Alright, so we've got one file. Seems like a lot of explanation for just creating one file that says hello, how are you, right? But we have to know the basics behind all of this before we can get into more advanced stuff, right? So we have file.txt, and let's make another file. Let's use nano this time. And we will say this file we want to call, we want to make a list of groceries. Okay, so I need some bananas, oranges, milk, bread, rice, and whatever else. There we go. So I've got a few things that I want to buy at the grocery store, and I'm just making a list. And to save this, remember I'm writing out to disk, Control O. I recommend you do this along with me if you've never used any of this stuff before. You can pause the video and create the file. Hit Control O. Now it's asking me, do I still want to save it as groceries.txt? Yes. And hit Control X. So now Control X exited out of the nano program, and now you see I'm back at my command prompt. Okay, this is called the command prompt because the computer is prompting me for input. How can I communicate with the computer? The computer just sits there until I give it a command. Okay, so it's prompting me for a command. When I enter nano, I'm no longer at the command prompt. I am in a different program. When I exit nano, it takes me back to the command prompt. Alright, so ls-al. Now we see we've got file.txt and groceries.txt. So I can display what's inside of groceries.txt with, oops, I've misnamed groceries. So let's change that name. To change the name, we use the move command. I've named it groceries. Right? So I want to move the file from groceries.txt to groceries.txt. Alright, so we see it's changed over here. We also see if I type ls-al, we've changed the name successfully. So now I can use the cat command and list out the contents of that file to my terminal screen. Now remember, the terminal screen, the output, is called standard output, standard out. You might see it displayed like that, std out. Okay, now the reason concatenate is called cat or concatenate is because it's used to join files together. Okay, so I have the cat command and I have file.txt, and I can join that output with groceries. So now it prints out the contents of file.txt and immediately prints that out, the next file out, which is groceries.txt. Okay, now what if I need to have a different list? It makes more sense if I had two lists and I wanted to combine them, right? So let's make another list. So we can do that with nano. We could do, say, nano, and we might need to get some camping stuff. Okay, so this is an empty file at the moment. We've opened nano. The name of our file is camping.txt, and I'm going to say, well, we're going to need a tent. We're going to need some chopped wood. We're going to need hot dogs, and buns, lighter fluid, right? Any number of different things, right? So I'm going to the store and I decide I need to combine my two lists. I have my normal grocery list, and then I have this camping list, stuff that I need to get for camping. So I can combine those. I can concatenate those two lists. Concatenate means just to join. So cat, I'm going to cat grocery or camping. Well, let's do groceries first. Groceries. Okay, and you see how when I type GR, it's filling out very quickly after that. That's tab auto completion. I'm pressing the tab character and it's auto completing because it recognizes that groceries is in this directory. So when I hit tab, it just fills it out for me. Okay, so that's a really fast way to move around. It's important that you know some of these shortcuts. So I'll explain them as I use them. All right, so I'm concatenating two files, groceries and camping. So I type CAM and hit tab and it automatically fills it in for me. Okay. So now I have my two lists. This is my grocery list, and then this is my list of camping supplies. Right? Now, I can take this output and move the new output to a master list. Okay, so instead of when I run the cat command, it just prints it to standard output right here. Okay, what it can do instead is I can print that output to a file. All right, so let's try that. Let's press up arrow. So this is our last command, and if I use the greater than symbol on the command line, that's saying take what would have been the standard output and put it into a file, and then the file name that you want to put it into. So this is going to be the master list.txt. Okay, and txt is an arbitrary extension. I don't have to call it tst. I could call it lst for list, right? But it's common if it's just a plain text file to call it txt. We'll go ahead and call it lst this time. And so all of this output that was print from the command last time, cat groceries and camping.txt, instead of printing out to standard output, we're going to get a blank output, but we're going to get a new file called master.lst, and all that data will be in that file. Okay, so we'll press enter here, and we see a new file was created on our desktop. Notice there was no output, there was no standard output. This redirects, the greater than symbol, it redirects standard output to a file. Okay, so now if I type ls-al, we see I've got master.lst, right, and we saw it get created over here. So now I can say cat master.lst. Sure enough, there's our list. I can edit it with nano. I can clean it up a little bit and say master.lst and get rid of some of the new lines a little bit. Save it. And I can say cat master.lst. So there's a nicer list. I've joined two lists together. All right. Now remember, these files are just text files. Okay, so every character, for the most part, is going to be translated as ASCII. All right, there are more advanced translations. Obviously, there are different languages, lots of different characters. The most basic character translation protocol is ASCII. All right, and so that's what we're learning first. Now I can see the number values that are actually stored in this file if I use the hex dump command. Okay, so let's look at what's inside of master lists. All right, these are the hexadecimal versions of every single character. Okay, over here, this is the actual text version after we've translated it. Okay, so instead of a new line, it's putting in a dot. So we see B62, so we want to look in here for the hexadecimal version. So the command name is called hexdump, so instead of looking for the decimal version of the number, we're going to look at the hexadecimal number. And we'll get in, this is just a number, a different number system, but the numeric values are the same. And we'll get into number systems here shortly. We're going to talk about decimal, hexadecimal, octal, and binary a lot. Okay, but just know that, for example, when we look at B, 62 is the hex version right here, and 98 is the decimal version. Those two numbers mean the same thing. They're the same quantity. We're just representing them differently. If we write the number in decimal, it's 98, and that's what we're most familiar with, right? Computers there's good reason why computers use hexadecimal and binary a lot. And so a lot of times if you get into computer science, you're going to see hexadecimal numbers and binary a lot. So hexadecimal 62 is the same value as decimal 98. All right, so as we look in here, we see 62 is the B. We have an A is 61. Right, and we go back to our ASCII chart. I see A is 61. All right, NANAS. Right, so every single one of these numbers is translated to a character. So when your file editor reads the data on the disk, it's reading these numbers, but it's also aware of this ASCII table, and it translates those numbers into the letters that you see. Okay, so when I use the CAT program, it reads the numbers from the disk and translates them to the character representation. So CAT master.list prints out all of these numbers as if they were characters, and it prints it to the terminal. Okay, so every one of these numeric values has a character representation. It's basically just a glyph. It's just a picture. So whenever you see this number, 97, stored on the hard drive, print out this picture to the terminal. So that's what's happening. So that is the basics of files and how data is stored on a computer disk. All right. So that's good enough for one video. So we'll move on to another video for more information. All right.